Today in this video we are going to study about how to solve NMR spectra. We will study how to solve NMR spectra in step-by-step process. Here as you can see, the four steps are given. This is the first step. This tells us that to calculate the number of the peaks that are given in NMR spectrum. Okay, if there are three peaks, it means there will be three kinds of protons. It means the numbers of number of the peaks tells us about different kinds of protons. Okay, and this is the second. Determine the chemical shift value. Chemical shift value is very important. It tells you about the types of the proton and about its environment as well. As in this third step, you have to find the integration value. It may be given in the or at the top of the peaks, like this is the peak, and it can be given here as the 3, as 6. This tells us about that how many protons are present in this peak area. And the fourth and the final step, deduce these structures by the information that you get from the earlier three steps. Okay, let's move to the first. This is the first spectrum, that is the IR spectrum. Actually, the compound that I have taken the three spectrum. First IR spectrum, second is C13, and the third one is Proton NMR spectrum. First of all, we will see that which information can we get from this IR spectrum. This is the 1718, and only the one peak is available. That is important, and the 1718 peaks tells you about the presence of carbonyl group in the IR spectrum. So this is the information that you get from the IR spectrum. And the second spectrum, this is the C-13NMR spectrum, and the two spectra are given in this. First is proton coupled, and the second is proton decoupled spectra. Here in the proton coupled spectra, this spectra actually tells you about the carbon atom as well as the attached proton, like this. If I tell you about this structure, can you see this structure here? If this carbon, this is C13 and this is C13, let's suppose. So here this carbon is attached with the three protons. So carbon itself gives one peak, and the three protons are attached, then the three peaks these, and this carbon will give you the quadrate, means four peaks will be due to this carbon atom. And you can also see this is also C13, and it will also give the peak in the C13 NMR spectrum, as this carbon is attached only with the two protons. So one peak due to the C13 and the two peaks due to the attached protons. To total three peaks will be due to this C13 carbon. It means that the one peak that is shown here in the proton coupled, this is due to the carbon 13 that is coupled with its attached protons. That's how this peak we get. Actually here we are getting the quadrate. It means this, there is a one carbon and it is attached with the three H atoms. So it means this peak is due to the CH3 group. Similarly, as you can see, this is also a quadrate, so this peak is also due to the CH3 group, and this peak, it is the triplet. So it means this peak is due to the presence of CH2 group, and this is the solvent peak, as you may see. And here one small peak is also shown here. If you see the chemical shift value here, it is above the 200 range. So any single peak that you get in the C13 NMR spectrum, and that is in the range of above the 200 then it is due to the carbonyl group. You should remember this. This peak is due to the carbonyl group. Okay, and here let's come back here. Here you may see that we have as already deduced these structures from the proton coupled spectrum, but here you may also see in the proton decoupled spectrum. This is the proton decoupled spectrum. As you may see here, this is the peak that is due to the carbonyl group, and here three peaks are given. As we have already deduced, these are the CH3 group, this is due to the CH3 group, and this is due to the CH2 group. Okay, next we will move to the proton NMR spectrum. Here, this is the important spectrum. As this spectrum, as the name indicates, only gives you the information about the proton NMR spectrum. So here you may see that only the 1, 2 and 3, it means that triplet. You get the first a triplet spectrum peak, and this peak comes nearly in the region of about 8 ppm. If you see, it comes in the region of 8 ppm. This means that this is due to the CH3 group. Okay, and the next we will see here. Here the triplet. First of all, we will see again this. I said this is due to the CH3 group, but as you already know from the previous spectrum, like you may see that the CH3 group, CH3 group and CH2 group is only present along with the carbonyl group. So here, come back to this structure. This is the CH3 group, but the 3 peaks are present. It means that the CH3 group is also attached with neighboring proton, and there are 2 protons. In the neighboring, there are 2 protons. It means that CH3 group here is attached with the CH2 group. How did you find it? You find it with N+1 rule. This rule says that N is the one kind of N is the number of the protons that are present in the neighboring of the some specific kind of proton, and the 1 is that specific kind of proton. Like here, this CH3, here these H3, all these comes in the same ppm value, but here these 2 protons, as you may see, in the vicinity of this specific kind of protons. So 2 plus 1, we will get a triplet like this. So this is the N+1 rule. Okay, and again come to this topic that this H3 all have the same ppm value. Why they have the same ppm value? Why? Okay, if you know the answer, you may give me answer in the comment section. Because this age, all these 3 types of the protons have the same environment, that's why they are coming at the same ppm value. And how do you know that these there is 3 protons in this peak value? We get this information from this integration scale, and integration scale here, it gives us the information that the 3 protons are present. And here this integration scale, as you may see here, this is also an integration scale, and it also gives the information that there are 3 protons present. And this integration scale, it gives us the information that here 2 protons are present. So these integration values are mostly given in this digitalized form, but if it is given like this, you may find it with the help of the scale values. If you don't know how to find the integration value in the scale, you may ask in the comment section. I'll make a video for you about that also. Okay, here we got the integration value. So this integration value show that there 3 protons are present here. So we got CH3 here, and the splitting pattern we find it by N+1 rule. This tells us that 2 neighboring protons are present, that is CH2 group. Okay, so we find this information from this peak, and here this integration value shows that 3 protons are present here, and the single peak is present. It means it is attached with that carbon which is not attached to any other proton. Okay, so this is the information that I got from this peak, and this is the last peak, and it is here, you may see this is the quadrate. Quadrate means that there are 2 kinds of protons. As you may see that 2 protons are present from the integration value. And how, if this is the one kind of proton, it means this is 1 plus n. N means 3. It means it contains 3 neighboring atoms, as it gives us the quadrate. So CH3 group, this is the CH2 group which is attached with CH3 group. Similarly, this peak also gives us the information about the CH3 group, which is attached with the CH2 group. It means that these two were peaks, first and this one, pehli first peak and the third peak. This gives us the information C about CH3 group that is attached with CH2 group, and this third peak gives us the information about the C first carbon atom that is attached with the CH3 group. So this carbon, there is no proton is present, but as we have already seen in the last spectra that carbonyl group is present, and from the IR spectrum it is also shown that carbonyl group is present. So from here you may also see that carbonyl group is present. So this is the structure of 2-butanone that you got from this NMR spectrum. Okay, what about now? The question is, what about if there is no NMR spectrum is given, like here you may see C13 or IR, you have not about the information about these two spectrums, then how you will find this structure of the 2-butanone? It's easy, you can still find this structure of 2-butanone. Let's move here. This is the 8 ppm value, which shows that there is a carbon there is a alkyl group is present. So this peak, it gives us the information at about in the range of 1.9, or at most in the, if you see clearly, this is almost in the range of 2. So the peak that gives us the information in this value about 2 to 2.3 region, 2 to 2.3 region, this is almost value, it is not exactly in the range value. This gives us the information that your proton is attached with any carbonyl group. So it means that here that your methyl group is attached with the carbonyl group. Similarly here, this also gives you the information about in the range of 2.3 ppm. This also gives you information that your CH2 group is attached with the vicinity in the, or with the carbonyl group, or in the vicinity of the carbonyl group. So like this you may still find this structure with the just the proton NMR, even if you don't have the C13 NMR or the IR spectra. Okay, here this is the structure of 2-butanone that we just deduced from the NMR spectrum. If you are given this structure and you are asked to draw the NMR, can you draw it? Give me answer in comment section. And more than that, if you have any query, you may ask